In this video, we're going to be talking about solving systems of linear equations and inequalities by graphing. First, a system is a set of two or more equations or inequalities. So in this example, we're asked to solve these two equations. Now when we're talking about solving a system, we're trying to find the value of x and y, or the values that meet both of these equations. So what value of x and y will make both of these equations true? So when we're graphing, we want to remember our slope-intercept form of a line. Y equals mx plus b, where m is the slope and b is the y-intercept. And for our first equation, my y-intercept is -1. So I plot a coordinate at negative 1 on the y-axis, and then I have a slope of -2. So I'm going to rise 2 and run 1, but in the negative direction. So down 2 over 1. And then when I want a point on the left side of my y-axis, I do the reverse, and so I go up 2 and to the left 1. It doesn't matter the direction you're going, as long as you're keeping your coordinates in a line. Now for this next equation, you notice it says 4y equals 4x plus 8. We want to get that equation in a form that we can easily graph. So what I will do is solve for y, so that we get an equation in slope-intercept form. Now to solve for y, I'm going to divide by 4 on both sides, leaving me with a y equals 4 divided by 4, 1x plus 8 divided by this 4, 2. So my new equation, y equals 1x plus 2. This is saying I have an intercept at a positive, my y-intercept is at positive 2, and I have a slope of a positive 1. We want to make sure we label our axes, x and y, and use a ruler so that we can maintain mathematical precision. You'll notice the problem that I'm having is I spaced out my tick marks on my axis too far. So you want to either make sure that you're evenly spacing it out, or you're using graph paper. We notice that I have a point where both lines intersect. This is considered my solution. And we want to write solutions in coordinate form. So -1 for x and 1 for y. So the solution to this system of equations is x equals -1 and y equals 1. Moving on from here, we have a system of inequalities. Inequalities we're going to graph just like linear equations, except there's a few things different we have to consider. When you have less than or greater than signs, your line will be dotted. And when you have less than or equal to, greater than or equal to, your lines will be solid. We're also going to talk about shading, but we'll do that after we have our graph. So we draw our axes, label them. For our first equation, or first inequality, we have y is less than or equal to 3x. So we have no intercept, so that means we're crossing the y-axis at 0, and we have a positive slope of 3. Once again, I just went in the opposite direction so that I would have points on either side of my y-intercept. Now notice I drew a solid line because that is less than or equal to, so I have a solid line. For this next one, I want to graph y is greater than x minus 1. I have an intercept of -1, and I have a slope of +1. So rise 1, run 1. Rise 1, run 1. Now remember, when it's just less than or greater than, we use a dotted line. So since there's not a or equal to part of my inequality, I have a dotted line. So now we need to think about the shading. For linear equations, our solution is the point that both lines intersect, whereas for inequalities, it's going to be a specific region because multiple points can fit that inequality. So for my first line, y is less than or equal to the equation for my line, so I'm going to shade the y values below the line, or less than. I'm doing this in pencil, and then I'm going to go over it in a darker pen so that we can see our shaded region. For the next line, y greater than x minus 1, we see that the y values greater than our line need to be shaded. So for the second, for my dotted line, I'm shading above it. And then in a different color, darker, we want to shade in the overlap. That's called our solution region. And so it's important when we're solving systems of equations and inequalities by graphing that we remember linear equations, the solution is where the lines intersect, and we have a solution region. So all the points within this section could fit these two inequalities.